This is an example of one of your subsurface scattering exercises, which I think yields a pretty good result. You can see that on the subsurface scattering X passes shader, we have the diffuse attributes are coming from a Lambert material. The specular attributes are coming from a Blinn material that's turned black, which is, as it should be. And then we have the weights adjusted, pretty nicely, so that we have a nice backlight coming through, especially through the thinner parts. One of the questions was that there is still a lot of sampling artifact in here, even though you turned the samples up to 512. Now I have them down at 256 here to kind of exaggerate them. But the answer is, yeah, it's not uncommon, and sometimes you're going to have to turn this up. So if I go up with a 1024 here, let's just save this and re-render. And I'm not sure you'll be able to see this based on the quality of the video, but sometimes upping the samples is a necessary evil. So this is with the samples set up to 1024, and this is 256. So you can see that there's a marked improvement. And samples is one of those attributes that you're just going to have to live with. If you have to bring them up, if you've done everything else that you can think of, then that's just something that you're going to have to build into your render time. So I wanted to show you another thing that you can do with this subsurface scattering shader. This is a candle, and it's going to have some light up here. So we would expect to have a little bit more light penetration up at the top and a little less down at the bottom. So that's what I want to address right now. Right now you have your, I'm just going to deal with the back weight because this is where the the light's going to penetrate and come through the back. You have that set at an even 0.8. And what you want to notice, what you want to realize is that's a scalar attribute going from 0 to 1. So we can tweak that with a ramp. So I'm going to create a 2D ramp, and I'm also going to create a surface shader just so that I can easily see what the ramp is doing. So I'm going to put this on the default, which is just the color of the ramp, and then I'll drag the ramp and put that on the color here. One thing I wanted to point out was that you didn't have any UVs laid out on here, so that as soon as I put that ramp on, the placement of the ramp was off. So I just put a cylindrical UV layout on here so that I get a better distribution. Okay, so what we want is a weight of some low figure down here on the backlight. So I'm going to take this red, I will take the saturation down to 0 so that it's just a black and white, and then I'll take the value and I'll bring that down to something like a 0.2. I'm going to get rid of the green, and for the blue I'll take the weight and I'll make that what your 0.8 was. So 0.8, and I'll take the saturation down again. So now we're going from a 0.2 to a 0.8 as we rise up the surface of the candle. I'm going to take this interpolation and make that an exponential up so that we get a little bit more concentration of that lighter area up here at the top. So once I've got that ramp created, then I want to apply that to the weight. Now there's a couple ways I could do it. I think that the preferred method would be to pipe that through a luminance node. Okay, so the reason is, as we've learned before, this ramp outputs 3 values, red, green, and blue, and the luminance node just multiplies them together and creates one grayscale value. So I'll just take the ramp and I'll make that the value of the luminance node, and then I'll take the value of the luminance node and I'll put that on the back depth of my subsurface scattering. So then I want to put the subsurface scattering back on the candle. So let's go ahead and render that. And so here you can immediately see that the back depth is now concentrated to the upper part of the candle and not so much down at the bottom. So we can compare these. That's what we had before, and this is what we have now. Now we can exaggerate that a little bit, and I think that that might work really nicely if we have, you know, a candle up here, a flame up here. So let's see how much we can push this. Let's just take the white value, and instead of 0.8, let's go to like you know, maybe a 1.4. All right, we'll just we'll push the value past the 0 to 1. So 1.4, and let's do a render of that. All right, so let's just save that. This is the 1.4, that's the 0.8, and this is the even distribution of 0.8 all across. So this is the ramp with the 0.8 up at the top, and this is the ramp with the 1.4 up at the top. Okay, so the only other thing that I wanted to do here was put my flame on here, and this was you know, just a pretty quick flame. Let's just graph the materials here. What I did was I created a blend material for the flame. I put it on a NURB sphere that's just stretched out, and a glow value on the shader, and I hid the source. So that way we're not going to see the geometry. I took the diffuse value, I put it all the way up to 1, and I put the incandescence. I gave the incandescence a little bit of a ramp here with blue at the bottom, and then kind of a pink going to yellow, and then white up at the top. And I took the color gain of that, and I dropped that down so that we're not going to get too much incandescence there. So when I render this, this is what I get. All I'm seeing is the glow from the candle flame, which is giving me a little bit of yellow because of that ramp. And because I have that 1.5 or 1.4 backscatter penetration up here, we're really getting a nice bias of the subsurface scattering towards the top of that candle. So I just wanted to, you know, add that to the mix and show you that this is some other stuff that you can do.